Then substitute 3x minus 5 plus 4x plus 6. 3x minus 5 negative times positive 4x equals negative 4x, and negative times positive 6 equals negative 6. Now 3x minus negative 4x equals negative x.
Now, I will show you an example of composition of functions. F composed of g of x, and that is equal of f of g of x. So we have the given g of x equals 4x plus 2 and f of x equals 3x plus 1. Find f composed of g of x. So let's solve f composed of g of x is equal to f of g of x. Let's first put g of x inside the parentheses. So what is the value of g of x? Let's look at the given. So our f of g of x is 4x plus 2. We just substitute the value of x. Now let's substitute the value of f of x. So we have 3 times 4x plus 2. Then copy plus 1. Then let's simplify. So 3 times 4x equals 12x. Then 3 times 2 equals 6. Then copy plus 1. Then copy 12x. 6 plus 1 equals 7. Then that's the answer.
So our given is x over x minus 2 plus 1 over 5 equal 2 over x minus 2. So what is LCD? So we have both x minus 2, have to take it out and only 5 remain. Our LCD is 5x minus 2, meaning this entire expression will be multiplied to the given expression or to the given rational equations transpose. Let's multiply this by 5x minus 2 and the other part 5x minus 2. So what will happen? We will multiply this one by 1. We have here 2 terms on the left side. So this become 5x times x minus 2 over x minus 2 plus 5 times x minus 2 over 5 equal 10 times x minus 2 over x minus 2. We eliminate the denominators, and then this 5 and 5, we can also eliminate both x minus 2. What remains here in that we only have 5x plus x minus 2 is equal to 10. 5x plus x is 6x minus 2 is equal to 10. Six x plus 10 plus 2. 6x equal 12 divided by 6. Cancel 6. The answer is x is equal to 2.
Intercepts and zeros of rational functions. The intercepts of the graph of a rational functions are the points of intersection of its graph and an axis, while the zeros of a functions are the values of x which make the function 0. The numbered zeros are also x-intercepts of the graph of the function. Find the x and y-intercept of the rational function, which is f of x equals x minus 4 over 3x plus 2. First, copy the given, which is f of x equals x minus 4 over 3x plus 2. Here, we can rewrite the given function to y equals x minus 4 over 3x plus 2. To get our x-intercept, we have to equate y to 0. 0 equals x minus 4 over 3x plus 2. Then cross multiply. So 0 equals x minus 4. Then combine like terms which are 0 and negative 4. From negative, it will be positive. 0 plus 4 equals positive 4. This time, we already have a value of x which is positive 4. Therefore, our x-intercept has a coordinate of 4 and 0. For the y-intercept, it is the same as the x-intercept. First, you have to copy the given, which is f of x equals x minus 4 over 3x plus 2. You can also rewrite the given function to y equals x minus 4 over 3x plus 2. Then, equate x to 0. So y equals to 0 minus 4 over 3 times 0 plus 2. So y equals 0 minus 4 over 0 plus 2. So y equals negative 4 over 2. Then divide, so y equals negative 2. Therefore, our y-intercept has a coordinate of 0 and -2. Next is determine the zeros of the rational functions, which is g of x equals to x minus 5 over x plus 2. First is copy the given, which is g of x equals x minus 5 over x plus 2. So here, to get the zeros of the rational functions, we have to equate the numerator to 0. Then solve for x. To solve for x, we can transfer -5 to our right side of our equation, so x equals 0 plus 5. Therefore, 5 is the zero of our g of x. Our next topic is asymptotes. An asymptote is an imaginary line to which a graph gets closer and closer as the x or y increases or decreases its value without limit. There are two kinds of asymptotes, vertical asymptotes and horizontal asymptote. Finding vertical asymptote. To determine the vertical asymptote of a rational function, first reduce the given function to simplest form, then find the zeros of the denominator that are not zeros of the numerator. That means we have to equate our denominator to 0. An example is determine the vertical asymptote of the rational equation, which is f of x equals 4 over x minus 5. To solve the equation, first is copy the given, which is f of x equals 4 over x minus 5. Then equate x minus 5 to 0. Then transfer -5 to the right side of the equation, so x equals 0 plus 5. Therefore, our vertical asymptote is 5. So next is finding the horizontal asymptote of a rational function. To determine the horizontal asymptote of a rational function, compare the degree of the numerator and the degree of the denominator. If the degree of the numerator is less than the degree of the denominator, the horizontal asymptote is equal to 0. Also, if the degree of the numerator is equal to the degree of the denominator, the horizontal asymptote is the ratio of the leading coefficient of the numerator to the leading coefficient to the denominator. And lastly, if the degree of the numerator is greater than the degree of the denominator, there is no horizontal asymptote. Here is an example of horizontal asymptote. Determine the horizontal asymptote of the rational function of f of x equals 4x plus 8 over x squared plus 1. So, to find the horizontal asymptote, first, copy the given, which is f of x equals 4x plus 8 over x squared plus 1. So here, by inspection, you can see that the degree of the numerator is 1 and the degree of the denominator is 2. As you can see, the degree of our numerator is less than the degree of our denominator. Therefore, our horizontal asymptote is equal to 0.
Solving exponential equations. Exponential equations are equations in which variables occur as exponents. Solve for variable x. The given is 2 raised to the power of x equals 4. So, 2 raised to the power of x equals 2 raised to the power of 2. So, the final answer is x equals 2.
A rational expression is considered simplified if the numerator and denominator have no factors in common.
Simplifying rational expression. Given are x plus 5 times x minus 7 over